Good, good. All right, well, thank you all for coming out, and to everybody who's online, thanks for signing in. Just going to go ahead and give a real quick introduction and tell you a little bit about Spaceport Innovators, and then we'll go ahead and get to the heart of this and why you guys are all out here. So, what is Spaceport Innovators? Spaceport Innovators is dedicated to making Kennedy Space Center a more creative and innovative place, and they do that a few different ways. The first is by promoting knowledge and idea sharing. And I think this forum, this particular forum today is a great example of that. We try to do a good job of promoting a diversity of ideas. So really stress that, if you come from a different point of view, we try to encourage dissenting opinions and work towards a better future with that. And then finally, the last thing is we do entrepreneurial activities. And really what that is it's us working together to take an idea to action. And so really a lot of our side projects and hopefully Dr. Yu here, this is a good example of how he's going to present an idea, and we'll see how it works out. But without further ado, let me introduce him real quick here. We met Dr. Yu, me and David and Josh, who helped lead Spaceport Innovators last week early. And my first impression of him was he's very excited and passionate about this topic. I don't think I've met anybody at the Space Center in a really long time who's had this amount of energy and passion devoted to anything. So his background, he's a senior scientist out here at the Space Center. He holds a PhD and MS in engineering physics from the University of Wisconsin-Madison. And then he also performed postdoctoral research at the University of Minnesota, Minneapolis for 2 years. And so after he first told us about this theory, I wasn't really sure exactly what to think, mainly because I don't know enough about physics to really understand the magnitude of what his theory is trying to capture here. And I did a little research online, and apparently Stephen Hawking doesn't think that the theory of relativity and quantum field theory will ever be reconciled. But I mean, really, what does he know? So anyway, without further ado, let's get started. Dr. Yu.
Thank you, Brad, and thanks to this Spaceport Innovators. Okay. They provided the best forum. It's a censor-free, promoted free exchange ideas. That's the best platform we have at KIC. So they are my heroes in pioneering this program. I'm really good. Okay, so first thing I wanted to let you know what at the stake today. It is entire modern physics hanging in the balance. So what I mean is modern physics, talking about non-Newtonian classical mechanics. So basically, say theory of relativities and quantum mechanics. We consider today. I know there's many people, young people, try to start the career by learning them. I would say sorry about it. Today, my mission is to point out the problems with this series, try to send to the place they belong to, 20th century historical museum of science. Okay, now let's back to okay. Disclaimer, because of the explosiveness of this presentation, so I'm obligated to disclaimer, say all views or opinions expressed here are solely my own and do not represent the views or opinions of NASA, U.S. government, and then waveform and the shape. So, okay. So now I'm free. Oh, by the way, thanks. I have a special guest. Two of the directors from NASA center headquarters. They are in charge for the Apple program. Director and the deputy director. They are all here, try to, support me. Without them, I will not be able to available with this room. So they kicked everybody else out, make this available for space innovators, for this young generation. Okay. Here's what outline I would have. I will have a brief introduction to physics and then talking about Einstein's relativity, quantum mechanics, and then present a new theory of everything called a single particle theory of universe. And then today I'm going to solve all the physics problems I know of. Basically, namely, wave particle dualities, electric charge, the origin of electric charge, and the quantum double slit test. I have talked to so many people, not even one people from NASA Kennedy Space Center have not heard double slit experiment. Today, I'm going to resolve the mysteries. And also, there's 4 categories: gravity, mass, dark matter, dark energy. That's all the stuff I know, problems I know in the physics. If anything, you have some more questions, something other, let me know. I try to solve them in real time. Here, this page I created to pay my respect or tribute to the greatest scientists in the world. I cannot read them name without sheer tears in my eye. So I'm going to just bypass that one. By no means insult all the world-class experts in this present in the room, and also underline. I know you are the best in every facet of the work you do. I do want you to pay attention to the logic, the reasoning, to the assumptions I made throughout the presentation, and we hope you make the whole project. So, okay, here's what I found. Here's what I found, the modern confusion. So I'm trying to say, what is the problem with the current structure of physics? So I found 2 problems presented. One is called a wave-particle duality. That's the foundation of quantum mechanics. Founded everything, so all the waves of the particles. Quantum mechanics summarize the entire world-made particles. I have no problem with that one. The problem is to say all the particles behave like a wave. So how particle could behave like a wave? Particle, we're talking about the rocks, raindrops or bullets. Wave, we know, wave means, the water wave.
I don't think anybody can hear me online. So.
Okay.
Hey, can you guys hear online?
Yeah, it's not real loud. It would be good if we could get a little bit louder.
And if everyone could put their phone on mute, please.
Is this any better?
Yeah, if you would like Dr. Williams that.
Maybe I switch this. Okay. I'm going to I switch to a different microphone. I hope people online, thank you for tying in. Maybe because my voice choked a little bit. So summarize entire physics was tied on 2 concepts. The first is wave-particle duality, mainly talking about the light and then all other quantum particles. All find that why particle behaves the wave. There's a central mystery I'm going to solve today. The second one is electric charge. Right now, there's no explanation whatsoever in the world. What is the origin of electric charge? Assuming this is born with it, right? And extended, so from electric charge, actually, nobody knows actually what is electron. I talk to my friends and say, we all know electron for over 100 years. So why you said we don't understand what the electron is? Yes, just because we don't understand what the electron is, that's why confusion. So let me just give you a little bit hint about where I'm going to. Why I'm saying the entire modern physics is hanging on balance. Nobody would doubt that we have a problems with theory relativities, because based on when a professor from State University of Arizona said just a couple years ago, right here, only 30 people in the world understand what theory relativity what talking about. Okay, so anybody believe you are expert in quantum in theory relativity? It's good for other people to know, But I said that after today you may think about it. You are fortunate that you are not belongs to 30 people. Okay, and the second thing is about we're talking about the modern physics. The second part is the quantum mechanics. We have been taught since our elementary school actually, say all the atoms made by what is a very small nuclei, say baseball size nuclei with electrons at a distance a mile away, circling around at the speed of light. Am I right? So far, that's what we taught. That's not true. Let me tell you. What they said is every fibers, every matters, every seat you are sitting is basically a nuclear reactor. Is accelerator, is a particle accelerator. Okay, because the electrons travel at the speed of light. If they will impact anything, it will have basically, I would think about a nuclear reaction or something. So if you trust your own instinct, this is not true. What that means, if there is no electrons circling miles away in an orbit, basically that says that there is no orbit. The orbit is a definition of quantum levels, right? So I'm telling you, if there is no free electron, and no quantum level, then there will be no quanta. There will be no Max Planck constant. There will be no Heisenberg uncertain principle. There will be no quantum mechanics. I hope you got it. You got the magnitude. So now I ask you use your entire, rigor and logic. Criticize me when I go try to demonstrate why this one is not exist. Because I found what is the make of the universe, and I use that one and try re-engineer to find out. Okay, so let's start off then. The first thing I think my purpose today is not to prove anything. I got a good advice from my friend Scott, because I already proved this one over the past 3 months without any shred of evidence. The discovery I have any conflict with any human experience. So I'm not going to try to prove anything to get it defensible, but I try to maximize the value, the new discoveries, try to share all the value with you. So the first thing, how did I started this one? That's on August 24th this year, just August, a little bit over 3 months ago. I suddenly find out one thing I realized. The light cannot be particle. That's something I realized. How? So let me first demonstrate what is a wave and what is particle. So this is I download this without sound. Download basically say if any particle sitting in a wave in a medium. When wave vibrate vertically, there's a particle itself circular around a fixed point. If you can, there's a center point fixed at a certain point. But the particle itself does not translate, right? It's not moving from A to B. It basically circulated, vibrated at the same location. I just try first to define what is the wave? If you look at this particle in the center, vibrate basically is vertically. However, wave transmitted the direction is horizontally. Got it? Okay. Now, let me make a little bit of test. Can anybody tell this laser point? I want to make sure in the back seat, in the corner, in the back corner seat, can you see the laser pointer? Okay. And on that, can that gentleman over that corner, can you see this laser pointer? Okay. What I try to demonstrate is that such a little laser pointer can see basically by anybody in the room at the same time, at a different distance, different angle, right? So let's extrapolate this phenomena. If we take the building out, so it's a reasonable assumption. This little laser point reflection from the screen can be seen by almost the people in the universe. Think about it. How many particles we can come up with this laser pointer? I saw people started nodding. Is that possible? We have a particles come out the laser pointer, fill the entire universe. Okay, let me go further. How many lights we have? Every single light, we see the lights, right? We are assuming particle. So every single light in the universe, we emit with a called particle, occupy the entire universe, multiply. Is that possible? For me, it's humanly, godly, heavenly impossible. What that led me to do? There's nothing more than only one option left. If light is not a particle, so light has to be wave. Okay, so now what is a wave? So we just watched that video. The wave, actually, I found out very interesting. Wave, all the engineers will say, we know the wave is a water wave, right? And more closely, actually, like sound wave. So the so-called sound wave is the definition, sound is a compressional pressure wave. It has a medium transmitter. So where comes the compressional? Compress is a pressure, right? Pressure wave has pressure. Where comes the pressure? So wave need a medium to transfer, need a carrier, mediator. So what is the mediator of light? That's where I started an entire new discovery. Since light cannot be particle, so only choice is wave. So what is transmitted the wave? So we know wave has had a medium. So the medium, so basically, whenever we see the light, we know have a medium. This medium has to cover entire, whenever light can travel, there is a material medium is there. So now let me ask further. So far, what I talk about, this medium, this light medium, I'm not the first one. I'm not the first one to see this one. However, it does missed by the greatest scientists, Isaac Newton and Albert Einstein. They always believed that light was particle. So if any of you so far still not convinced, how could the light is only wave have nothing to do with particle? You are not alone. Okay, and I even myself before August 24th, I always believed that light was a stream particle. At that time, I tried to formulate string theory, because I was that was 15 years ago. First time I heard string theory, which consistent with my principle is, number one, particle do not have a frequency. Frequency, or called frequency, is wave characteristics. Individual particle do not, unless the particle, do some kind of, is a part of an elastic medium, have an elastic property, elastic vibration, and then have a translation. So that's part of this one. So now, let me assume we have no problems with with the particle, with light is a wave. So now I might ask another question. What transverse wave? Okay, what type of medium can carry this light, right? So now we know light has to be carried by medium. Now I wanted to know what the type of characteristics of this medium has to have. This is actually pretty simple. This problem is solved by James Clerk Maxwell. When he united electric field, magnetic field, and light, what he says, light is a magnetic wave, right? It's a transverse magnetic wave. Okay, but in his mind, he thinks a magnetic wave is a mathematical term. He talking about the mathematical, why? He still think that the magnetic wave is transmitted from a vacuum. Not have a carrier or something. But today, I'm gonna say his theory is correct. I just want to add one piece. The medium is not a vacuum. It is a magnetic medium. So magnetic medium means every single particle has a magnetic feature. So basically, what I said is here. So light or electromagnetic radiation is a transverse wave / vibration of magnetic fluid. And these fluids saturated entire visual space. That means whenever we can see the light, we know have a medium vibrating. So we know have matters. Remember, dark matter, dark energy, we said we're missing matters, right? We have matter all along. The reason is we just cannot measure it. You know the reason? Before I talking about the density, now I'm trying to characterize what's the density of this matter. Before I go that one, let me say the light carrier. I define that the light carrier is a universal fundamental magnetic particle. I named it called the universal, use U, a particle use on, any particles, photons, muons, or whatever, they all, electrons, they all have on as a particle. So I named it called a U-on, okay? Means it's a universal fundamental magnetic particle. These are the particles vibrate in the medium, carry light, got it? So we have a magnetic fluid, and we know the particle is a magnetic particle. So now, what causes light? That's the question. Another one. Whenever I talk about it, they wanted to know what causes light. Is nothing more, just a moving magnet. Whenever you have a moving magnet in a magnetic field, what happens? You're moving entire field, magnetic field, will respond. Just because you're changing, when you have a moving particles, because of distance change, all the particles are relative direction, relative to your change. When they change, they have a chain reaction. The entire field is changing, right? So that's a carrier and the source. Current definition of light. So we see all the lights. What causes light? We know only electron travels through the wires, right? Through the cables. Electron. What is an electron? I told you nobody right now understands electron correctly because they don't understand what is electric charge. Let me just give you, electron is nothing more just a little magnet. So when little magnet goes through the wire, what happens to the magnetic field? It excited every single particles in surroundings and then generate light. Well, why sometimes we see the light, sometimes we don't see light. Depends on the size of the moving particle, moving magnet. Electron size actually very significant. I will tell you in the next page. This page, I try to demonstrate this is another concept. So we know light has a carriers, has a medium. So I try to use this, all the evidence I have, say, what's the evidence? We are surrounded, we are soaked, we are immersed in this huge magnetic fluid, right? We are in there because we can see light. Light is transmitted by magnetic particles. So we are immersed. So what's the evidence you have? So basically, this page, I would say, if we look at it, this is a Milky Way galaxy. You just look at the picture from afar. You will see the connections. You will see all these arms connections. These are, if you very easy to do a test in a water flow. You will see. I have a video. I'm not going to show this video because I worry about that. The copyright belongs to individual. So it will formed exactly. If you have a water flow, you just play in bathtub or something. You will see form exact pattern. That means in order to have this kind of spiral arms, it has to happen with the surrounding with fluids. Another one is a Gauss particle. I have a video for that one, but I'm not going to play right now. Let me see if I have a video embedded here. No, not embedded. You know the Gauss particle? That's a Peter Higgs. I'm very respect this gentleman. This gentleman just win his Nobel Prize October 8th this year at his age 84. You know what he win? He win this Gauss particle. You forget about it, this Gauss particle, whatever. Actually, he made one important discovery. He realized light was wave, not a particle, when he was at 1965, and he published a paper. I believe it's 1966. Published a paper, introduced, say, wow, universe is a field. It's a field with the matter. For that one, I respect him. However, now I get credit. He already won his Nobel Prize. So I'm very happy for him because if he passed this year, I do not expect anybody in quantum mechanics will ever win a Nobel Prize. Okay. His particle is just one part of the puzzle for a fundamentally problematic theory, quantum mechanics. In quantum mechanics, everything works except they find out the missing matters. We do not have enough mass, right? That's their problem. So then they have to create the one particle, give other particle mass. So this is what a Gauss particle. Gauss particle said, universal field saturated everywhere of the particle. The density is so high. So any quantum particles we can think about it, protons, electrons, everything moving through this medium will got a resistance, high resistance. So then they say, increased resistance is equivalent to increased mass. I know we are Newton classical mechanics people here. You will sound funny, right? They do believe called moving mass increase with velocity increase because of resistance. I will tell you that later. So for that reason, so I was so happy he got rewarded a Nobel Prize because he realized an entire space filled with matter. So I don't have to spend a lot of time to convince anybody because in the modern physics arena, it becomes official. Okay, so there's some other things. Personally, I think that every time we use cell phone, where comes the cell phone signals? Is this wave, this magnetic fluids? We are saturated, right? So very simple. And another thing is dark matter, dark energy. We are missing matter in one time, in one place, so we said missing matter, but in another place, we give away a matter. We say the entire space is empty, is a vacuum. There is no vacuum. I probably have something. And another thing I just want for personal reason. I just came back from Wisconsin, met with my advisor. He's a professor and a department chair of engineering physics department. That's where I get my degree from, and at the University of Wisconsin-Madison. So, I just fly the airplane, sit on the airplane, you will see all the clouds is beneath you, and sometimes I see why it looks like an ocean type of a green color, right? Like a clouds flow in the ocean. You know what that means? Whenever you see clouds, you mean there is a field with fluids heavier than clouds underneath, right? So that's basically just tell you we are living under the sea. That's another way to say it. So hurricane. If you look at a hurricane, cream always on top of what? You know, on top of fluids, right? So we know. Personal experience is all conformed to one thing. We are immersed in this saturated fluids. If you get this one, I would have an easy time to explain what's going to happen with a double slit test. Okay, so that's why I'm spending so much time. Okay, so now let me talk about the density. The density of this one, because if we know the density, then we know how much matter we're missing, right? We can calculate how much dark matter we're missing. Oh, let me explain the bottom left first. That's a prism. That's the Newton's baby, right? He coined the word called a spectrum. He used this kind of prism, find a spectacular view of the lights. You know, the white lights coming in and being spread out. So he coined this word spectrum. However, even Isaac Newton believed light was particle. He believed there's a particle coming in and reflected and came out reflected again. This weekend I spoke to one gentleman. He finally got it, and he asked me, he said, if light is a particle, so we should only see the lights at the direction when lights came out. He said, why can we see from anywhere? Basically, he's answering the question, light cannot be particle. That has to be wave. We can see the light from everywhere, not just from the particle coming in and came out, right? I still want to convince this one because the reaction I got from audience is not instantaneously. Don't worry about it. No one, at least